And for your understanding, let's see example 2.3. So GL is given as 100 ohm plus J50. G naught is given 50 ohm. So this transmission line has a 50 ohm characteristic impedance. GL is terminated. So the problem asks about the admittance of this YL. So this is normalized at GL, but we can convert to YL, right? And then if we have this length is about length is 0.15 lambda, then we can also calculate G in, right? So G in also can be converted to YN. So we can do math, and then by inverse of GL to YL, then we can get the YL value. But this problem asks about the has to use Smith chart to get YL, so the admittance. So let's see. So GL is normalized. GL is 2 plus J, right? So let's say normalized YL is one inverse of normalized ZL. So if we put it in calculation, this simply is this, right? So we can use two-way, right? So to get this YL, so first is use Smith chart. Only have with only impedance circle, right? So R and X circle. And two is use SC with impedance chart and admission circle together, right? So let's see this Smith chart with only impedance information. So GGL is 2.2 plus J, right? So if you see that in Smith chart, you have this point, right? 2, this is plus J, right? So this point, this is normalized GL. So because this Smith chart only have impedance, to convert this YL to GL to YL, we should have we should find the point which is opposite according to this origin, right? So if I draw line, so this value is somewhat here, like this. So for this, I recommend use alright. So I use. So let's make straight line. This, and then with the same length, if you use your compass, right, this approximately, this will be the point with the opposite point according to this origin, right? So this value become YL. So if you read the value here, then you can easily convert YL value, right? YL is, you can get the YL value from this GL. So it's 0.4 minus 0.2, right? And then, so what it asks is Y in, right, with 0.15 length lambda, right? Transmission line. So this point, let's see the point here, right? So this is 0.46, about 3, right? if you read this position, so this transmission line length will make this rotation, right? So this should be 0.15. So if you add 0.15, 316, right? So because this scale 0.49 and then it turned to 0.0, right? So which is 0.5. So it again increases, right? So to get this value, you should minus 0.5, so which become 0.113 lambda. Because here 0.5 becomes 0, so we read this value, right? And then we should find the point is 0.113. So this is 0.1112. So the value will be here, right? So if we draw a line from here to there, so this is this represents 0.5 lambda. So point is about if you have a circle that should be perfect to find. So approximately, so value is here. So this is y in, right? So we move from here to here. So the value we find is y in is, this is 0.6. If you make circle here, about 0.65, right? So this is 0.6 plus j between this 0.65. This is normalized y in, right? So that from this, so we can convert that to admittance. So admittance times y0. So here is a characteristic admittance is inverse of characteristic impedance, right? So that this value is 0.6 divided by 50. So this is about 0.012 plus j 0.132, right? So this is Gmans. So this is YL we found from this Smith chart, right? And then also we can use this same problem with this Smith chart with the Smith chart together. So let's check this. So this was normalized GL is 2 plus J, right? So it's easy to get this point. We should use a red circle, right? This is representing resistance circles, constant resistance circle. And we have this one, right? So this point. So because this chart has admittance information, so we can read this value, right? This value and this value, so that we can get YL plus is 0.4 minus J 0.2, right? So for this chart, we don't need to rotate 180 degree because this chart already have all the conversion inside. So you can just use this value, so which is same, right? I mean, so no matter which chart we use, the value should be same, right? So if the value should be is same, then you are doing a correct way. So because this problem asks 0.515 lambda transmission line, so that we should rotate 0.15 lambda, right? So we start from here, so which is about 0.2212, right? Plus 15, 0.362. So 2225. So this is increasing, right? Keep increasing. So that if you read this value, 0.36 and 37, so you can pick this point, right? So from here to here is 0.15 lambda transformation, right? So which means 0.15 lambda from this GL or YL, right? Whatever, this value, right? So this point represent YN or GN. So I can draw a line. So that we can pick a point, right? So if you see the point, so it will cross 0.6, so about this point. This magnitude should be same, right? So the point will be 0.6 0.6 and about this point. So y in become 0.6 because this is a plus for the B, right? As acceptance, so we should plus, and so this one, the point is here. The point is if you read the blue chart, is here, right? So it's about 0.65. So which is same value, right? Which is same value, so that we get the same yn at this kind of input admittance. So that either way, if you use this chart or previous Smith chart with only impedance information, you can get correct value of this, right? So so if you have either of them, you can do it if you don't have any confusion, right?